real education now on MTD CNC. We're at Rigor Precision in Newmarket. We're about to look at quite a unique work holding solution that's been set up on this Doosan machine. Gio, you're a work holding specialist. You've had many years in supplying kit like this. Talk to us about what we've got here with this microlock system.
Yeah, thanks, Paul. I think that when you're looking to set up a work holding solution in your machine tool, no matter what machine tool it is, it's absolutely imperative to get the right work holding solution to be able to use the machine tool to its full capabilities. That's the first thing. And what I mean by that is, firstly, you want to reduce any vibrations, so you can run the spindle speed at its full speed. You can do the fastest feeds and speeds and really get them parts off as quickly as possible. So when it comes to a mechanical system like the microlock, you're achieving the clamping force required for the part not to move. You're getting pull down force, and you've got options of hard jaws and soft jaws. So from that perspective, it meets the requirements, it ticks the boxes. But
how's that going to affect the vibration though? So I mean, the vibration will come from the spindle and the machine, won't it? Or are we saying that?
So when you have particular work holding solutions, if you're not holding that part securely, so for example 1960s technology, when you've got a solid fixed jaw, you'd have deflection in that fixed jaw. So effectively you're actually only holding the part pinpoint. You're not actually holding the part down the face because the jaw is at an angle. So you're not holding the part securely, and subsequently what will happen there is you'll get vibration, chatter on your part, and to overcome that you'll have to do one or two things. Firstly, you'd have to reduce your feeds and speeds, and maybe even your spindle speed, or you may have to introduce a finishing cutter to compensate for the bad surface finish. But that will also have a bad effect on your tooling costs as well, because it will increase your tooling costs and the longevity of the tools will be decreased. So when you're talking about...
And potential wear of the machine as well.
Absolutely, absolutely. Longevity of the spindle as well. So just from having pull down force, the right clamping force, you benefit in all them ways, which a lot of people actually overlook, which is absolutely a cardinal sin in my opinion, Paul.
Okay, so that's the clamping mechanism, and we know the microlock as being a referencing plate, so you can position things quickly and clamp them securely. But here what I'm seeing is it in between a fourth axis unit and a tail stop, and you've got the same underneath as well, so we've got double bubble. That's the right word.
I think this is a perfect setup, and Joe really went to town with this setup, and it's really helped his efficiency. Now, what you've got here and the advantages of this, if you were presenting a profile part, say for example, onto the machine bed in a vise, you can hit the part from only one angle, and you can do any internal pockets in a profile. And then you turn it around, obviously do op 2. But when you've got six-sided work, where maybe you've got a pocket on each face, you can do them six-sided works now, which some people do on a fifth axis machine, on this particular system in 2 operations. So now you can do that, Paul, is, say for example this is the part. So you present the part to the spindle for op 1 in that orientation. So the spindle will be hitting the top, and maybe you do a profile, a pocket. Then to do op 2, you'll rotate your fourth axis rotate to 90 degrees, and you can do the top face, and then minus 90 degrees, you've done your third face. So that's 3 faces complete. And even you can do any angles as well, if it was a 45-degree angle, whatever the case may be. So that's the first operation, and you've hit 3 faces. You've achieved adjacent side milling. Then for your second op, where you load at the other end of your spindle, that component then gets presented to the spindle in that orientation, and then you do that face there and your other 2 faces by tilting there and there. If that makes sense.
Right, so that's essentially one machining cycle to do a complete part. If you had a 5-axis machine, you'd need to do 2, wouldn't you? Because you need to turn
exactly
over.
The same. But it's 2. You're holding that part twice. Yeah. You're holding the part twice in this setup, but you're presenting more parts to the spindle.
Correct. So you're getting more parts, but also with a 5-axis machine, you do have to stop and potentially turn the part over, don't you, to finish the back face.
Yeah. So what the other advantage? It's a good point actually. You're getting longer run times, but in a good way, because say for example that particular part, you have a look at the length of this trunnion, you could potentially present 4 or 5 components per face. So that could be potentially 4 or 5 6-op work in one setup. And that's what you've got to think of, one setup. So you can walk away from that machine. When you come to unload the machine, you've got 5 6-sided prismatic parts complete.
Yeah.
So the efficiency gains are astronomical. And I think we touched upon this in a recent podcast that we did, Paul.
Interesting, because we talk about BMCs being sometimes less than 35% efficient. You're now taking this machine well beyond that, aren't you? You're increasing it. You're making sure that even though you've purchased just a 3-axis machine, you're optimizing its capability to improve that efficiency no end.
I absolutely love it when I see a setup like this, because someone's actually thought about what they're doing and using their machine tool, as we mentioned at the start of this interview, to their full capability. What's the point in spending a lot of money in a brand new machine tool if you're not using it properly? There's no point. You're getting the maximum output for this machine tool, and just by adding a 4-axis rotary table, a tail support, and some fantastic innovative work holding from Microlot, the benefits that you're getting are astronomical. So for the smallest investment, you're getting the biggest return of investment. And as we mentioned as well, not only the amount of productivity gains that you get, but the savings from your cutting tools, the longevity of your spindle.
So much to think about when it comes to what is the best solution, isn't it? It's great to see things like this in evidence. In fact, today we're here at Rigor Precision, and this machine and this system has been installed here for the exact reasons that we've been talking about. Microlock is a flexible work holding system well beyond what you sometimes see on our channel, and this is a great example of that.